So we just said earlier, for constant acceleration, acceleration is the velocity change per second. It's meters per second per second. The total velocity change is thus found by multiplying acceleration and time. What? Here's what I mean. Acceleration is the change in velocity per time, where change in anything, Kiana, is final minus initial. If I get the delta V, the change in velocity by itself, I would move the t over. How would I move the t over? What's the t doing on the right-hand side? So I could also write this as change in velocity equals at. Kiana, what's change in anything? Something minus something. I know, it's tough to say for some reason. I butcher it all the time too. Try again. So I can write this as V final minus V initial at. Fatima, I'm going to derive some equations with you. You don't need to know this part. This is me as a nerd, just wanted to show you where this comes from. And I'm going to get the VF by itself. How would I get the VF by itself? How would I move that minus VI over? Yep. I get this. Which, Deegan, is the equation that I gave you about half an hour ago. Okay. Put that in your back pocket, but remember it's there. In the box, we can write VF equals VI plus AT. By the way, I will almost always put a little curly thing on my T so you can tell it's not a plus sign, because if I do that, it's tough to tell whether that's a lowercase t or a plus sign. This is the first of the kinematics equations. And on your formula sheet this year, I think, is it the first one, second line down? Oh, I got it right here. I got one finally. Yeah. We're going to be deriving that whole line today. Those are the 4 kinematics equations. That's it. Yeah, if you take physics 12, it's these same 4. In fact, really, we get away with 3 and kind of, anyways. To find the distance or the displacement that an object travels, we can't use d equals vt like we did in our distracted lab yesterday, because that's only true for constant speed when you're not speeding up or slowing down. However, if we use our definition for average velocity, which allows you to speed up or slow down and then just take an average, we can say that v average equals displacement over time, and I can get the d by itself. How would I get the d by itself? Multiply by what? More specific, please. So I get this. Displacement equals write that down in the box. Except now we're going to talk about what do we mean by average. Let's suppose that Max has $10 and I have $20. Between us, what do we average? Someone said it. Okay, when I do that, that usually means say it louder. Is that Owen saying? I can't tell. Loud and proud. How do you get a 15 from a 10 and a 20? Mathematically, what would you do with those two numbers? Did you go 10 times 20? No, that's 300. How do you get a 15? George? Add, to find an average, you add them together and divide by 2. So I'm going to make a little note here. V average is V initial plus V final divided by 2. And Peniel, I'm going to stick this right into there. I'll get this. D equals VI plus VF divided by 2 times T. Is that the second equation on your list of 4 there? Second line down? Oh, Kiana, how many variables are there in this equation? How many different versions of this equation are there? You can memorize all 4 different equations, or I can teach you how to rewrite these in your head. Go with the second option. It's better. Little note, this again assumes uniform or unchanging acceleration. You can step on the gas, you can hit the brakes, Ethan, but once you've stepped on the gas, you can't press harder or less, or once you've hit the brakes, you can't press harder or less. We want a constant acceleration, not a changing acceleration. Gets ugly and you need calculus. So if we have uniform acceleration, we can find average speed written by VAvg equals VI plus VF divided by 2. I think that's what I wrote up in the box there, yes? Add them up and divide by 2 to find the average of any 2 objects. Okay. We're going to start with this line right here, D equals VAvg T. Is it turn the page? Turn the page. D equals but instead I'm going to write this as D equals VI plus VF over 2 times T. That's the second equation. Okay, there it is. But the first equation said that VF equals VI plus AT. Max, can you read me this equation the same way I just did? Read it again. You're right. Read it again. What does VF equal? VI. What does VF equal? Wherever I see a VF, what can I write instead? So what can I replace this VF with here? That's what we're going to do next. Okay, we're going to get this. D equals, I'm going to drop the vectors for a while because it's going to just clutter things up. I'll bring the vectors in at the end. Big bracket, VI plus, what am I going to write instead of VF? And then there's a times T, and this whole mess is over 2. Pause. Again, let me emphasize, I'm not going to ask you to derive this on a test or a quiz. This is just to show you where these equations come from. What's a better way to write 1 VI plus 1 VI? 2 VIs. I'm going to combine those 2 like terms. D equals 2 VIs plus AT all over 2 times T. Now, I'm going to multiply that T into the brackets. I think Mr. Rocca calls it front door bomb or something. You're distributing. I've never quite understood that. Anyways, okay. I'm going to multiply the T onto everything. Zena, that's going to give me D equals 2 VIT plus A. I could write TT, but what's a better way to write T times T? Psst, we're trying to generate the third equation. We're almost there. If you look at your green formula sheet, you can kind of see where we're headed. Is this divided by 2? Is this divided by 2? Is everything being divided by 2? Then I can split them up. I can write this as D equals 2 VIT over 2 plus AT squared over 2. Why would I do that? Because that first fraction, Annika, is there a 2 on the top? In the first fraction, is there a 2 on the top? Is there a 2 on the bottom? Well, hey, they cancel, just like we were doing for unit analysis. And you get this. D equals VIT plus, I could write AT squared over 2, but for some reason we write a half AT squared because dividing by 2 is the same as multiplying by a half. Which of these are the scalars? Time. So you can put vector symbols over the D, over the VI, and over the A. D equals VIT plus a half AT squared. Kiana, how many variables does that equation contain? How many different equations are hidden inside of it? How many variables did the previous equation contain? 4. How many equations did the previous equation contain? In fact, what you're going to hear me say is, if I know 3 things, I can find the 4th. There's going to be 5 things altogether: time, VI, VF, A, and D. If you give me any 3, I can find all 5. Because in any equation, if you give me 3, I can find the 4th, and then I can go to a different equation and find the 5th. The last equation I'm not going to derive because it takes a while. It's this one. VF squared equals VI squared plus 2AD. If you want to see where this one comes from, I can show you later. These are the big 4 equations, second row on your green sheet, and this is what you're going to be going to time and time and time again. Normally, I would say for the next month and a half on the linear system, for at least the next week on whatever this system is. Sometimes, instead of VI, especially if you're British, you'll call VI V0 because that's the V at time 0. Except, does anybody know, they don't say V0, they don't even call it a 0 in Britain. What do they call a 0 in Britain? It's a naught, N-A-U-G-H-T. And so they would read this as VF equals V naught plus AT. I had a British high school physics teacher, so you may hear me say that sometimes because it's how I learned it. Or if I'm stealing stuff from the internet, you may see this notation. I will almost always, when I'm writing, use initial and final because it just makes good sense to me. But V naught is V at time 0. It's initial. These are the 4 equations. We're going to do some examples today purely algebraically with numbers, and then we'll dive into the word problem applications next lesson. I use an approach that I call DFIC. Now, DFIC stands for list your data, find a formula, insert the numbers, and calculate the answer. This is just a hook or a gimmick to help you if you don't know how to start. You're going to notice partway through the year, we'll abandon this because we'll be good enough that we can cut some corners. But when in doubt, DFIC, you'll hear me say. And I think the other acronym that I gave you was DALP, which stands for draw a little picture. Especially in physics 12, when we go 2-dimensional, you'll hear me say to kids when they ask a question, did you DALP? Did you DFIC? No, I'm not going to help you yet. I've done the listing of the data for you in today's assignment. So example number 1, I have VF equals 29.6, VI equals 3.2, A equals 2.9. What's this question asking me to find? So normally I would write down, don't write this down, T equals question mark, but notice how I did that for you already? Okay, so here's what I'm going to say. There is one equation of those 4 that has a VF, a VI, an A, and a T in it. Which one? This you have to be able to do by the end of today's lesson. Select the correct equation. So look at your green sheet. Which one? Aiden, which equation? You were zoning out, so you're back. No. Read me the equation. We're not plugging in numbers yet. Equation. From your green sheet. So you didn't have your green sheet out. You're back with me. You're zoning out. So you ready? There are 4 equations. Only one of them has a VF, a VI, and a T in it. Which one? Read it. Don't go to the sheet. Go to the green sheet. Don't point on the white sheet. I want you to get used to finding it on the green sheet, on the front page of the green sheet. Second line down, Aiden. These are the 4. Yeah. Okay. Okay. Don't look at the 4 equations up here because you're not going to have this on your test. Deegan, you're going to have the green sheet on your test. So why not train your eyes to start looking in the right location? That's the correct equation. What am I trying to find, Aiden?
Trying to find T.
Put a dot above the T. I'm trying to get that by itself. You're going to be tempted to start plugging in numbers right now. Do not resist the temptation. I really want to teach you how to rewrite these equations algebraically. Aiden, what side of this equation is the T on? Left side or right side? Left side's going to drop down like a domino. Do that. What's right next to the T? What else is on the same side as the T? What's the A doing to the T? How will I move it over? What's the VI doing to the T? How will I move it over? Which one am I going to do first? Reverse BEDMAS. So I'm going to minus the VI. Write that down. Don't write this next bit down. In my Sesame Street imagination, I just imagine the AT dropping down like a domino. What am I trying to get by itself? How will I move the A over? How do I know? Divide the whole side by A. That equals T, but Annika, I'd prefer to go T equals, so I always just move it to that side. Kiana, here is yet another equation. Do I need to memorize it? Sure, no. I would say no. Yeah, she went like this. No, I'll teach you how to derive these. Otherwise, you can memorize 16 different equations. Don't do that. Now, Aiden, I go to numbers. What's VF?
VF is 29.6.
Minus, what's VI?
3.2.
All over. What's A? Everybody get out your calculators. If you have the fancy schmancy fraction button, use that. Otherwise, is there more than one thing on the top? Brackets around the top. Is there more than one thing on the bottom? Don't need brackets around the bottom. Do you get 9.10344827.6? Okay. Now, how many sig figs? Well, 3 sig figs in this unit, but just to review for your quest later on today, 29.6, how many sig figs? 3.2. Wait a minute. On the top, we subtracted, so we should have counted decimal places. 1 decimal place, 1 decimal place. We would go to 1 decimal place, and then we would do our sig figs. Forget it. We're not going to get that complicated. This is why I abandoned sig figs in Unit 2. So I'm going to call this 9.10. Aiden, 9.10, what units? What did we find?
9.
So? Yep. And then I have a habit of putting a little box around my answer. This is like spiking the football after a touchdown or making a little victory dance. This is my haha. So what you're going to do is try and figure out which of the 4 equations we're going to use. Write that down. Then we'll rearrange it if necessary. Example 2. Example 2. Ariana, what are they asking me to find in example 2? Okay. And it looks like they gave me a VI, an A, and a t. So I'm looking for the only equation that has a d, a vi, and a t in it. There is only one. Which one, kiddo? You read them. Don't tell me first, second, or read them. Yep. Because they're not in any order. Like when you say the third one, that could be the first one on someone else's, some other teacher. So they're not in, there's no formal order here. What am I trying to find? Get the D button. Ha! Already is. Bonus. Plug and chug. So it looks like it's going to be negative 1.5 times 12 plus, how would I type 1/2 into my calculator? 0.5. Someone said 0.5. You can put the 0 in front. I know I don't need to, and I'm lazy. I saved myself a keystroke. And yes, I count. And then 12 squared. Stop before you start to type. Notice, Nick, I used brackets when I was handwriting because that's way easier, but I'm not going to include all these brackets on my calculator. I'm going to use the times button. So everybody get your calculator out. Clear it. Negative 1.5. Make sure you hit the negative button and not the subtraction sign because they're different. I'm not going to go bracket. I'm just going to go times 12. Plus, oh, I missed a number, didn't I? In front of the 12 squared, I need an a, so I need to move this over. It's a half a t squared. I made a typo, sorry. Time plus 0.5 times 4.5 times 12, and then I have an x squared button. That's by far the easiest way to read it on your calculator. So I would encourage you, don't bring in all the brackets and stuff. Hit equals. Ariana, what'd you get? 306 even? That works for me. By the way, here's what this means. What was V initial, Ariana? We started out going backwards. What was my acceleration? But we were accelerating forwards, so I guess we must have come to a stop, turned around and started going forwards. And from where we started, we ended up 306 meters in front of where we started. Even though we started out going backwards. That's why this is a displacement. We must have gone backwards for a while, but we turned around pretty quickly and came forwards and ended up way up there. A lot of information baked into here. Units? Okay. Cool. Nick, what's example 3 want me to find? First of all, what's it want me to find? What's got the question mark next to it? Okay, it wants me to find VI. What else did they give me? A, T, and D. So I'm looking for an equation that's got a VI, an A, a T, and a D in it. Which one? And read it. I think it is. So read it. By the way, the reason I'm saying read it, this is partly how you'll intrinsically start to memorize them without meaning to, but even subconsciously, your brain will start to look at the right area. So I'm being fussy. Did you say D equals, keep going? Good. What am I trying to find? Let's put a dot above it. What side is the VI on? Left side's going to drop down like a domino. Kutunk. There, I've written something down. I feel better. What's right next to the VI? What's the T doing to the VI? So, remember that. And then there's also a plus a half AT squared. And that's all one thing. What's the half AT squared doing to the VI? Adding. So how do I move the half AT squared over? Which one am I going to do first? Reverse BADMAS. So the D dropped down. I'm going to subtract the 0.5 AT squared. I changed the 1/2 to a 0.5. In my mind, Nick, don't write this next bit down. I see the VIT just sitting there, but I imagine that. How will I get the VI by itself? More specific, by. I think you're right, but I couldn't hear you. Yep. And then that equals VI. Nick, do you mind? Can I put the VI equals on this side instead? Kiana, do you need to memorize this equation? Say no. I'll teach you to derive these. Again, don't try and memorize all these. Apparently, another equation for calculating the initial velocity is displacement minus 1/2 times the acceleration times time squared divided by time. Okay, plug and chug. D is -40. I guess we ended up 40 meters behind from where we started.
Yeah.
Minus 0.5. We accelerated backwards at 3.5 meters per second for 24 seconds. Don't forget the squared. Is this a fraction? Yep. So if you have the fancy schmancy fraction button, use that. Otherwise, definitely brackets around the top. Do I need brackets around the bottom? Open up a bracket, -40, take away. Notice how the subtraction sign and the negative look different on your calculator, because they are. 0.5 times -3.5 times 24 squared divided by 24. If this was a word problem, it would have gone something like, how fast would I need to start out at if I want to end up 40 meters behind from where I started after 24 seconds of accelerating backwards at 3.5 meters per second squared? And apparently, I would have to start out going 40.33333 positive forwards. I'll go 40.3 sig figs. Units, Nick. Units. What did you find? So what's velocity measured in? Yep. Sorry, but meters was a bad guess. Because look, go look. What'd you try and find? It'll always tell you what the units need to be. That's why I do this method. Example 4. George, what am I being asked to find? I'm looking for an equation that has a VF, I guess a VI, an A, and a D. There is one. Look at your green sheet, which you have in front of you. Stop looking at that white sheet. I don't know. I'm waiting. Yep. 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 What did you say they're asking me to find?
Oh,
so I need to get the VF by itself. Oh, it is! Or is it? Ooh, it's VF squared by itself. How would I get rid of a squared? What's the opposite of squaring? So what you can do, cross out this squared and put a big square root like that. I changed colors just so you can see what my thinking was. You don't need to. Is the VF by itself now? Plug and chug. VF is going to be great big square root 12.5 squared plus 2, 9.8, 126. Who has the newer Casios with the fancy smanchy fraction button? I think when you hit your square root button, it actually does a little mini window inside the square root, so you folks can just go. For the rest of us, here's what I tend to do. If I'm doing a big square root, I actually type what's inside the square root first. I go like this, 12.5 squared plus 2 times 9.8 times 126. I hit equals, and then I go square root answer button. I do that, and I got 51.24. If you don't know how to do that, if you can't find your square root, now is your chance to ask. I will come around and assist. Let me pause the video lesson for a brief moment. I got 51.2. George, units.
Meters per second.
Yep. How do I know? It says velocity. Ooh, I think I can even do this. Let's get fancy schmancy. Oh, I don't want that one. Let's get fancy schmancy now. I did. I think I can even paste this. Oh, look at that. That's good notes.
What? How do you do it?
Okay.
Screenshot?
Example 5. Are we next page or next page over? Cool. Max, what are they asking me to find? Acceleration. By the way, if this was a word problem, it would say something like a car is going at 12 meters per second. It accelerates to 20 meters per second in 86 meters. What was the rate of acceleration? Okay, we'll get to the word problems next class. So we're looking for an equation that has a VF, a VI, an A, and a D in it. There is one. Which one? Is it really?
Yes.
VF squared equals VI squared plus 2AD. Okay. Again, you don't need to memorize those 4. They're on your sheet, and you'll bring them to every test and quiz. What am I trying to find? I'll put the little dot above it just to help me track it. Eventually, we'll stop putting the dot there. We'll just kind of imagine it there. But what side of this equation is the A on? The right? What's going to drop down like a domino? Left side. VF squared. Also, you'll notice I stop the vector symbols in the middle because it just clutters up everything. I just make sure my final answer is okay. All right. What's right next to the A? Hint, there are 2 things. A D and a 2. What are the 2 and the D doing to the A? So, remember that, remember that, remember that. What else is on the same side as the A? I got to be fussy. It's not a VI. A VI squared. What's the VI squared doing? So how will I move it over? Which one first? Reverse BEDMAS. So it's going to be minus the VI squared. In my imagination, I'll imagine the 2AD has dropped down to the next line. How would I get the A by itself? Well done. Divide this whole thing by 2D. That is yet another equation for acceleration. VF squared minus VI squared all over 2D. Kiana, do I need to memorize this? Okay, let's write out the numbers. We always write out the numbers until we get good. 20 squared. Oh, no, careful, Mr. Dewick. VF is 12 squared minus 20 squared all over 2 times 86. Is this a fraction? Well, then you're going to use the fancy schmancy fraction bar. Those of us that don't have that, is there, Max, more than one thing on the top?
Yes.
Is there more than one thing on the bottom?
Yes.
Brackets around the top and brackets around the bottom. One more thing. What was my final velocity as a number exactly? What was my initial velocity? Am I speeding up or slowing down?
Slowing down.
Am I expecting a positive acceleration or a negative acceleration?
Negative.
If I get a negative, I won't freak out. I'll relax. I can make a prediction if I'm paying attention to the numbers. So, clear it. Bracket 12 squared minus 20 squared, close off the top, divided by bracket 2 times 86. Close off the bottom. I'm expecting a negative answer. Do you get negative 1.4883?
Yeah.
I'll call it negative 1.49. Yeah. Always. So if you get a fraction, you have that on your calculator. Show me your calculator. It's either S to D. I showed you how to change fractions, decimals on there already. Yeah, hit that. Yeah, in physics, we want our answers as decimals. So negative 1.49. Units, it's an acceleration. I like example 6, I like example 6, I like example 6. Example 6 is a nice question. Why would I say that? Really? You heard me say that? No, you're just a student that tends to notice those things when a teacher emphasizes stuff? Good. Deegan, what are they asking me to find in example 6? Which equation? I don't know. You have to read these. Stop. Did you read VF to me? I don't know VF. Can't use it. And by the way I find the correct equation is I actually say there's 5 things. Which one's missing? Don't read any equations with that thing. So I already said, I don't know VF. I'm not going to read an equation with VF in it. And that narrows it down to 1. Deegan, read it out. Probably the equation, especially in physics 12, will end up using the most. What am I trying to get by itself? Why is getting t by itself a problem here? There's more than one t. Okay? Who are my grade 12s? We call this a quadratic equation, and you in grade 11 will do an entire unit on how to solve this. Right now, you can't solve this unless I give you a special subcase. And that's what I did. Deacon, what was VI? What's 0 times 5 in your head, please? What's 0 times 10 in your head, please? What's 0 times anything in your head, please? What's 0 times this t in your head, please? Because right now, I can only ask you to solve this equation for time if VI is 0 and this whole term cancels. And we get yet another equation, a special subcase, and it looks like this. D equals AT squared over 2. Mr. Durick, I thought it was a half AT squared. Yeah, multiplying by a half and dividing by 2 are the same thing, but that looks way prettier, I think. Okay? So actually, Kiana, this equation has a 5th special subcase, not just 4. What am I trying to get by itself? What has a question mark next to it? Good. Okay, I can do this. See the t, see the t, see the t? There's an A. What's the A doing to the t? So how will I move it over? You know what? Let's be lazy. I'm going to do this. I'm going to cross out the A and just tuck it down there. And there's a 2 on the bottom. What's that 2 on the bottom doing to the t squared? So I'm going to cross out the 2 and tuck it right there. And that gives me 2d over A equals t squared. Equals t what? Ooh. How do I get rid of a squared? I'm going to cross out this and put a big square root here. We'll use this one fairly often. T equals the square root of 2 times d over A. It's going to be the square root of 2 times 2,400 all over 20. Again, you have one of the newer calculators. I think if you just press your square root button right now, and then inside your square root button, since this is a fraction, press your fraction button, I think you can actually type it all in there in one step. I was looking at your calculator. For me, I have to go bracket 2 times 2,400 divided by 20 equals square root, answer button, and I get 15.5. 15.491, 15.5. Units, Deegan. What did we find? What did we find? So time is measured in meters? Yeah, here you go. Okay. Don't panic for units. Always, what did I find? That's the units. Yeah. Press your S to D your button or your fraction decimal button. Did that work? No? Okay, I'll come and look at yours in a bit. So yours gave you an answer of, let's see, square root of 240. What can I pull out of there? Probably a 16. So 4, I don't know. I'll look at it later. What's your homework? All of these. If you look, Owen, okay. If you look, what I did on the very, 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 very last page, I scrambled all the answers. So you'll find when you find an answer, go look, you'll find it here somewhere. Okay? There are a couple I haven't talked about on purpose. Specifically, if you're looking for a couple of, let me think, let me look. Number 10, I haven't talked about yet. Number 9, I haven't talked about yet. I'm going to see if you can figure out how to rewrite that equation. If not, I'll talk about it on Monday first thing. And I haven't talked about... I did that one. I did that one. I did that one. Might be one more in there I haven't talked about. I can't remember. It's done on purpose. So we're done for today. I'm going to say it's 10:56. In about 10 minutes, we'll start the quest. Take a little break. You can work on your quiz corrections, do any studying that you need to do. And I'll come and help Alessio with his calculator.